Okay, so let's look at another example of method of undetermined coefficients. So we have this differential equation. What we do is we start with the auxiliary equation, the homogeneous version of the equation, my bad. So now the auxiliary equation is m square minus 2m plus 2 is equal to 0. And then, well, we have to use quadratic formula here. We cannot factorize it. If you do use the quadratic formula, I will give you the answer. So the root will be, what you get is 1 plus or minus I. So it's a complex root. So alpha is 1, beta is 1. So the fundamental set of solution will be e to the alpha x, e to the 1x, cosine beta x, cosine 1x, e to the alpha x, sine beta x. So this will be the fundamental set of solutions. Okay. So I did that fast because we saw that plenty of times. Now we look at the right hand side. So it's 2x minus 2. So what will be your first guess? This is a linear function. So my guess will be, it will be like ax plus b. Now do we have an initial? Do we have an overlap with the initial guess? No, right? We have completely three different functions. So we can stick with this initial guess. Now what we do is we need to substitute into the non-homogeneous differential equation. So let's find y prime. So if you differentiate ax plus b, you get a. Second derivative is derivative of constant is 0. So much nicer. So let's substitute. Y double prime minus 2y prime plus 2y is equal to 2x minus 2. Okay. So y double prime is 0. So 0 minus 2 times y prime is a plus 2 times a is ax plus y is ax plus b is equal to 2x minus 2. So if you simplify the left hand side, minus 2a multiplied by 2, 2ax plus 2b is equal to 2x minus 2. Let's group the similar terms together. So x terms 2ax, constant terms are minus 2a plus 2b is equal to 2x minus 2. Alright, so now if we look at the coefficients of x, here it's 2a, here the coefficient is 2, which implies a is actually 1. Okay, alright, now let's compare the constant terms. Minus 2a plus 2b is equal to minus 2. Now a is 1, so we can substitute here. Minus 2 times 1 is minus 2 plus 2b is minus 2. Minus 2 cancel out. So 2b is actually 0, right? So that means b is 0. Because we cancel out everything, you don't have anything on the right. So a is 1, b is 0. So our particular solution is ax plus b. So it's 1x, it's just x. Nice, right? Then our general solution will be c1 e to the x sin x plus c2 e to the x cosine x plus the particular solution x. So the first part is the complementary solution, second part is the particular solution. So that's our general solution. Now if I remember correctly, we have two initial conditions, y0 is 0, y prime 0 is pi. So we have to use both of them to find c1 and c2. So y0 is 0, y prime pi is 0. Okay, so if you use the first condition, when x is equal to 0, y is 0. So y is 0 when x is equal to 0. So if you substitute 0 for x here, we get c1 sine 0 is 0. So c1 times 0 plus c2 cosine 0 is 1, e to the 0 is 1. So c2. So c1 times 0 is 0. So c2 is 0. Okay. Alright, now to find y prime, to use this initial condition, we need to find y prime here. So if you differentiate once, c1, we have to use product rule here, e to the x sin x plus c1, well we know c1 is 0, so we can get rid of c1, we can just have c2, we just have c2 e to the x. Oh no, we know c2 is 0. So we just have c1. c1 e to the x sin x plus x, right? c2 is gone. So if you differentiate these to get y prime, c1 e to the x sin x plus c1. If you differentiate sine, it's cosine. We use the product rule there. x differentiated, it's 1. So now if you substitute pi, y prime pi is said to be 0. So this is 0, c1 e to the pi, sine pi is 0, plus c1 e to the pi, cosine pi is negative 1. So here it's negative plus 1. Okay, so then this part is 0. So c1 is actually, if you take the 1 to the other side, c1 e to the pi negative is equal to negative 1. So c1 is negative 1 cancel out. So c1 is 1 over e to the pi. So it's e to the negative pi. So c1 is e to the negative pi. Then we can write the final solution. We know c1, which is e to the negative pi, e to the x, sine x. c2 is not there, it's c2 is 0. So this is the general solution from here. Okay, I think I used different initial condition than the note. So in the note I have used a different initial condition, so you can practice that also. Okay, all right, thank you.